Assalamu alaikum. So today we will solve an example of stopping power, how to find stopping power when a particle hits, when a charged particle hitting some material penetrate into that. So we're supposed to find the stopping power. So here is an example. What is the stopping power of a 5 mega electron volt alpha particle moving in silicon? Means an alpha particle, charged particle is coming with an energy of 5 mega electron volts and it penetrates into the silicon. Now it's up to you. You have to find the stopping power of this alpha particle. So as we know, the formula of stopping potential basically dE by dx. We all know this is the stopping power in mega electron volts per meter. This must be in mega electron volts per meter. This basically equals to 4 pi r naught square z square mc square divided by beta square and capital N capital Z bracket. Now what you have to do here, ln, then this is the complete formula, mc square divided by I beta square gamma square bracket closed minus beta square bracket closed. So this is the complete formula to find the stopping power of a charged particle like alpha. If electron, so the formula change, but in the case of alpha particle means heavy particles, so these formula should be applicable. Now here are some factors like you can see this r naught is basically the electron charge divided by mc square, and when it multiplies by 4 pi square, so it's basically 4 pi r naught square basically equals to its constant 9.8 9.98 into 10 raised to power minus 29 meter square, which is basically approximately equals to 10 raised to power minus 28 meter square. But if you want in centimeters, so it basically 10 raised to power minus 24 centimeter square. So this is the value of 4 pi r naught square you have to put here. And Z you already know, basically it's the atomic number. The next factor is basically the gamma. What basically gamma equals to, the gamma is basically equals to, I should write here, gamma is equals to capital T plus mc square divided by again mc square, and which is again equals to 1 divided by under the root 1 minus beta square. So this is the value of gamma, where capital M is basically the rest mass of particle, and beta is basically, is basically v by c, where v is the velocity and c is the speed of light. And this capital N is basically the number of atoms per meter cube, that is moving inside the material, and the other N, this N, this is basically the number of atoms per meter cube, and this capital Z is basically the atomic number of the material, and this small z, you can, I already told you, basically this is the charge of an incident particle, like z is equals to 1 if there is a charge of, so what should be the charge of alpha particle, you already know. So capital Z for alpha particle is 2, but if that electron, positron, proton, neutron, then it should be z equals to 1, small z. Capital Z is basically atomic number of the material. In our case is silicon, so our capital Z D is basically the atomic number of the this silicon. And what does this I basically means the mean excitation potential, mean excitation potential of the material. This is here another formula for I. Let me write here. I should be in electron volts, so it's basically equals to 9.76 plus 58.8 capital Z minus 1.19 into capital Z. Okay, so this is the formula for ionized, basically what I should say, mean excitation power potential of the material. Okay, now let's start. These all are the aspects. Now we are starting to solve our problem. Our problem says, what is the stopping power of 5 mega electron volts alpha particle moving in silicon? Okay, so as we know, what is the atomic number of our silicon, so our capital Z is basically equals to 14. Okay, this is the atomic number of silicon, so obviously the mass number should be 28. Okay, so mass number should be 28 for the case of silicon, and this should given the raw density of silicon should be 2.33. if we don't know, this should be given in your problem. Basically the density of silicon is 2.33 kg, okay, per meter cube, because it's density. Okay, now this is given, this is given, this is given, these are all constants, these are constants. Now the important thing, we have to find beta from this formula. Okay, and we have to find gamma also. Okay, so what is the formula of gamma? As I told you, let's find first gamma. Okay, so as I told you, gamma is equals to this. Okay, what's our energy? 5 mega electron volts, as it is given, because this T is basically the energy, okay, of that particle, plus mass, because alpha particle has mass of 4. Okay, you know alpha particle is basically the helium particle, and helium has a mass of 4. Okay, so this is capital M is the mass of the coming charge particle, 4, and c square. C square, what's equals to c square? You already know c square basically equals to 931.5 mega electron volts. Okay, you already know this. So this multiplied by 931.5 divided by again this 4 multiplied 931.5. okay, now after substituting you will get your gamma, which is equals to 1.00134. now this is the value of gamma. Now you need the value of beta. What you have to do, as you already know, gamma is also equals to this, so move this to this and gamma downside. What it becomes? Under root 1 minus beta square. This comes upside and gamma goes downside. 1 divided by gamma, taking square root on both sides. Okay, so what it becomes? It becomes 1 minus beta square equals to 1 by gamma square. Again we need to find beta, so beta square becomes equals to 1 minus gamma square. Okay, and you already know the value of gamma. Just put the value of gamma and you get but you have to just putting the value of gamma. You know the value of gamma, 1 minus 1 divided by 1.00134 square, and you will get your value of beta, which is now becomes equals to 0.00268. okay, after calculating you will get the value of beta here. Now all things are now given. Now what you have to do, you just have to find the value of this I. Okay, this I. Now just let's find the value of I with this formula. Okay, now we are finding the I. As we know, the formula I in electron volts is basically equals to I in electron volts is basically equals to this written here. Okay, 9.76 plus 58.8 capital Z minus 1.19 into Z. Now you already know capital Z is basically equals to the material for silicon, and we already know that the capital Z is equals to 14. Now you have to put the value of capital Z. You will get 9.76 plus 58.8 capital Z value is 14 power minus 1.19, again whole multiply by 14. After substituting, what answer you get? You get 172.1 172 into 10 raised to power minus 6. Okay, this is the final expression you get after solving this. Okay, now this is the value of I. This is in mega electron volts. First, this is only electron volts. The actual answer is this. Okay, 172 electron volts. Now you convert it into mega electron volts. So 172 into 10 raised to power minus 6 mega electron volts. Now this is the value of I. Now what you have to do, you just have to put the value of I, beta, gamma and all other values into the main formula here. Okay, so let's put the value here. Our dE by dx, which you all know, basically the stopping potential. Then what we have to write here, the value first, 4 pi r square. We know that in meter square its value is 10 raised to power minus 28. So we can write 10 raised to power minus 28. So this is the value of 4 pi r square. Now we have to put the value of small z. You already know, I told you that small z for the case of alpha particle is 2. So 2. Okay, 2 square. Next thing, you have to put the value of mc square, and mc square basically equals to, as I told you, c square is this, and basically m is the mass. Here is mc square, and you already know c square is this, and mc square is equals to, mc square is basically the rest mass of an electron, and its value is basically 0.511. okay, mega electron volts. Okay, the value of mc square is also in mega electron volts, and how its value is equals to 0.511 mega electron volts. Now you have to put the value here, 0.511. the value of mc square is done. Now you have to put the value of beta square. The value of beta square is this is the value of beta. You can take the square of this, and you will get the final result, 0.00268. okay, 268 square, and the value is this for the case of beta. Okay, this is, you can see beta square value is this, 1 minus 1 minus gamma square. So 1 minus 1 minus gamma square. So this is basically the value of not beta, this is the value of beta square. Okay, but if you want to beta, you can take square root on both sides. So this actual value is already the beta square value. You just have to put 0.00268. Now beta square is done. Now what you have to do, you have to put the value of n. And what is this capital N? Let me know what does this capital N means. Basically this capital N, here I write to explain you, this capital N is basically first of all the density into number, Avogadro's number divided by their mass number. Okay, so this basically the actual value. Na, we already know what's the value of Na, 6.022 into 10 raised to power 23. And what's the value of A? I already told you the value of A is 28. Substituting, multiply it by omega, you will get your answer. So let's solve this to find the value of capital N. Okay, so what's the value of omega rho, which is the density? Here I write the value of rho is this, 2.33. okay, multiplies by Avogadro's number 6.023 into 10 raised to power 23. okay, divided by their mass number, which is 24, and you will get your final answer, which should be equals to, first right here, let me show you. Rho density multiplies by 2.33. This is kg. If you want grams per meter cube, so multiply 10 raised to power 3. okay, so now this is in grams per meter cube. okay, your density. Now you should multiply it by Avogadro's number, as I told you, 6.02 into 10 raised to power 23 divided by their mass number. What's the mass number? Basically, as I told you, the mass number is 20. okay, All done. Okay, because we convert this in our what I say, in grams, so this should be in grams, so that's why we multiply it by 10 raised to power 3. If we wrote 2.3 t as it is as here, then we no need for this. Okay, then we no need for this. Okay, all done. You just have to multiply in denominator with 10 raised to power minus 3 with the mass number. Okay, this basically the mass number. Now a done. Now the next thing is the value of capital Z. You know the value of capital Z is 14 as I mentioned here, and our next step is to substitute value here, just bracket, and we have to anti-log, then we have to substitute the value to multiply MC square. You already know 0.511 basically is the MC square, and divided by I, which we already find here. Okay, 172 into 10 raised to power minus 6. This is in mega electron volts. Okay, now beta square value is this. Okay, you already know 0.00268. okay, and this multiplies by final gamma square. Gamma already we find this. You can take the square of this, 1.00134 square. Okay, that's all. Now denominator is same as it is, bracket close. Again, last thing is minus beta square, minus this value. Okay, 0.00268, bracket close. So this is your final expression. You just have to calculate, and you will get your answer. Okay, let me substitute and find the answer. After solving this, you will get final relation is 1.48 into 10 raised to power 5 mega electron volts per meter. Okay, you can also convert this in joule per meter by converting mega value 10 raised to power minus 6 multiplied by 2 and electron value multiplied by 1.6 into 10 raised to power minus 19. So you can convert mega electron volts per meter into joule per meter. Okay, in joule per meter it's basically equals to 2.37 into 10 raised to power minus 8 joule per meter. So that's all. Okay, here your answer is also correct. So that's all for this problem. So in this problem we basically find the stopping power when an alpha particle with having an energy of 5 mega electron volts comes into a particle of strikes inside, penetrate into the silicon. So here we find the stopping potential in mega electron volts per meter, or you can also find in joule per meter. It's up to you. Okay, so here how you can solve this type of problem. Okay, the only thing, this formula you have to understood, and these constants should be given, like density for pi r square value m naught c square. You must know this equals to this. Okay, you know the formula of gamma, and from this you can find beta and easily, and this formula. Okay, the value of I formula which I told you, and I already told you I basically is the mean excitation potential of the material. So you must have to know this value. Okay, mean excitation potential of the material, or this an approximate equation of I which gives good result for when z is greater than 12. Okay, this formula gives the best value when your z is greater than 12. So here you can see our z is greater than 12. Yes, it's 14. So this approximation is good for this problem also. Okay, so we can use this formula. Okay, so here we find d by dx, which is the stopping power of the material. So that's all for today. We solved an example today of our this course, nuclear tracks. Okay, so thanks for watching. Stay tuned with us. Allah Hafiz.